this person created the meeting, and this ought to be the person joining, and this is the remote person joining. And yeah, so if this was deployed, basically you would have seen the other person, but obviously I'm the one testing and I'm the one doing the same at the same time. So yeah, so before we get into writing some code, I would want to paint a picture of how WebRTC actually works, because it's quite different from WebSocket. All right. So for WebSocket, you would have a particular server sitting in between both clients. So WebSocket is not necessarily a peer-to-peer connection, because each peer would have to send their message via the server, and the server delivers it to the peer, and vice versa. So it's more like a client to server, server to client communication mode. But WebRTC is different. WebRTC actually allows both clients to communicate with one another without any server sitting in between. And that's why WebRTC is actually favorable when it comes to video streaming, all right, because of that low latency. However, that's not how it works from the very beginning, all right. There are some processes that allows both clients to communicate freely, and that's what I'm going to be explaining. So it took me a while to be able to wrap my head around what was happening here, especially how WebRTC actually works, because it seems a little bit much more complicated than WebSocket. Because for WebSocket, it's just a direct communication to the server. But for WebRTC, something has to happen first before that two-way communication, bi-directional communication would start to happen. So I'm just going to explain to you as best as I can. All right, so you can just read up on it as well. So let's say you have, let's say this is client 1 and this is client 2. All right, so these two clients wants to do a video conferencing or just want to do a video call, something like that. And we want to assume or believe that the underneath software is using WebRTC. All right, so the first thing that happens is, the first thing you should concentrate on is this signaling server, because this signaling server is what makes more like an handshake. They need to have some form of handshake first. All right, so client 1 needs to know some things about client 2, and client 2 needs to know some things about client 1 to be able to agree, come to terms that they can actually communicate with each other without the need of any third party. All right, so that is the reason for that signaling server. And what they will be sending to each other is what is called offers. This is called offers. So client 1 is going to be sending an offer to client 2 via the signaling server. Client 2 checks the offer. The offer basically consists of some information about client 1. So client 2 checks the offer and then sends back what is called an answer. So step 1 is an offer, and step 2 is an answer. So client 2 sends back an answer, right? So you see some terms like local description, remote description while we start to write the code. That's basically what's happening. So they send all of these things via the signaling server. All right, and for us, we are still going to be using WebSocket. All right, you can actually use anything. You can tweet the offers, you can send the offers via WhatsApp, but because this is an application, so we're going to be using WebSocket to act as our signaling server to send that offer, and client 2 receives the offer, checks the offer, and agrees if he wants to be able to communicate with client 1. If he's fine with whatever offer client 1 is sending, client 2 is then going to send back an answer, right, also containing some information about client 2. So that's how that bit works. Once the two of them are able to exchange this bit of information, originally, all right, because we are on our local, originally, they should be able to start communicating with each other using WebRTC. But there comes another complication, right? And the complication is the fact that most of the clients on the internet hide behind a firewall. All right, there is more like a firewall um, blocking each client just so that they do not suffer attack. All right, and they are usually behind what is called a NAT server. A NAT server. All right, so that is where this stun and turn server comes into play. You need this turn and stun server to be able to help you, not necessarily bypass, but to be able to legitimately communicate with the other clients or whichever clients you want to communicate with that are behind a NAT server. All right, so it's more like a security concern, but yeah, once the most important thing is that client one sends an offer via the signaling server to client two. Client two checks the offer and sends back an answer to client one. And because of the complication of NAT, firewall, and the likes, you'll be seeing something like ICE candidates. That's where stuff like ICE candidates comes into play. Candidates. Man, all of this terminology actually spinned my head upside down. So you might also just try to check them out, see how they actually works. I might not be able to go in depth, but I'm going to add some materials in the description below that actually helped me to be able to wrap my head around all of this. But yeah, I hope you understand the overview. This is actually how it works, and this is what we are going to be writing. This is what we are going to be coding up on the project using Golang. Okay, so let's see where we last stopped. I'm just going to go screen to a little below. Just increase the font. Okay, so I'm just going to do go run main dot. I'm just going to go run. Okay, that's 8080. So let's do localhost. That's 8080. Okay, great. All right, so this was where we stopped last time. Awesome.
All right, but first you'll have to unlock your device.
So we were able to exchange chats. I'm going to create another client here. All right, so it's the hello there. Okay, that worked. Hello there. Hi. All right, so I think this was where we stopped last week. We're able to establish communication, bi-directional communication using WebSocket, and this works. But in this particular section, what we want to do is to enable video conferencing. All right, and let's get right into it. Okay, so okay, so where do I start? All right, so I already created some folders here, so I'm going to be creating rooms.go. Also going to be having signaling.go. So rooms.go is going to contain everything about my room, and signaling is going to act as that middle server. All right, that middle server that helps with exchange of offers and answers. How would that make sense to you? be good because everything is going to be in our video package. And we're also going to have join room. Those are the two endpoints we're going to have. So the ability to be able to create room and the ability to be able to join a room. Somebody has to start the call. So whoever starts the call is creating the room, and whoever gets, and when you create a room, there will be a random room ID created. So whoever wants to join the call can simply paste the random UID and initiate the join API or button for the client. And that should be able to get that client into the same room with the person who actually created the call. So I hope that makes sense to you. Yeah, we're going to be using mutext because we do not want issues with deadlock or issues with race condition. So we're going to be protecting this particular resource so that when a particular connection is trying to get a room, trying to get an information about the room, it's not going to affect all other, it's not going to allow any other connection to be able to do that at the same time concurrently. So that's why we're going to be using this here. So we're going to be locking, going to be doing a read lock and defer text. So all we're just trying to do here is to be able to use run to generate random room ID. So remember I said when the user creates a particular room, video conferencing room, it generates a room ID. And with that room ID, every other user can join that particular room. So all we're doing is basically to generate the room ID. So we've generated the room ID. We're adding the room ID into our map, and we're initializing the room with an empty participant list. Makes sense. And we are returning the room ID. Now we've successfully created the room and we've returned the room ID. The room has been created with empty participant list. Now let's work on inserting users into the room. So what we've basically done here is to add the participants as part of this particular room object. Okay, that's fine. I think this has to do with tooling, Ghost tooling. The package has been added, so it's going to sync up later. This is actually everything we need for our room to be able to perform all of this functionality. So let's go straight to working on signaling. All right, so for our signaling, there are two major functionalities that we need, which is create room request handler. Okay. Okay, so this is quite simple. Basically, just created a map with all room, and because this method is obviously tied to room map, we're able to create a room that gives us a room ID, and with the room ID, we are able to do an encoding on the room ID with the JSON response, and we're able to send it back to the front end. So creation of room is basically simple. Once you create a room, you get that room ID, more like your meeting code, if you will. So joining a room is actually where the bulk of the work lies. The first thing we need to do is, obviously, you know that instantiating a WebSocket connection basically starts from the standpoint of HTTP, because WebSocket is basically your HTTP. All right, so starts from the standpoint of HTTP, and your HTTP has to be upgraded to WebSocket. All right, so that upgrading process is what we're going to be doing now. So this is what's going to be responsible for upgrading our HTTP connection. So basically what we are saying here is we are expecting that if you're going to be joining a room, you ought to pass the room ID as part of the query parameter. So that's what I'm trying to get here. So if we do not get a room ID as part of the query parameter, then that will be a problem. We would not be able to move forward. So we'll just do a log. Okay, that's not the case. We can simply grab our room ID, because this is going to return more like a collection. And the next thing we need to do is we need to broadcast a message. We need to broadcast a message to everyone that is within that particular room. So we need to broadcast a message to every client that is, or every participant in our terminology, if you will, within that particular room, that somebody just joined the call. That's the notification you get when somebody joined a particular call, right? So that's what we need to do now. So we're going to make a broadcast channel. Broadcast channel will be responsible for accommodating every message that needs to be broadcasted. Message underscore room ID. You can get the room ID from message, because don't forget, this message is basically your broadcast message, and your broadcast message has the room ID. So you can use this to get the particular room, and on getting the particular room, we can fetch out the clients from the particular room. So now the way it works is, if I'm joining a particular room, I don't need to get the notification that I joined the room. All right, other people need the notification, not except from myself. So we need to filter that out, because if it's equal, message your client, because if it's equal, that means we are going to be sending to that client, and we don't want to broadcast the message to clients. We only want to broadcast the message to every other person that is not the client. So we can broadcast. We're going to run that broadcaster as a go routine. I think we're pretty much done here. All right, so that's basically it. It's quite easy. Created our room, created our signaling.go file that helps us create the room and also handle users that needs to join the room. What we're going to be doing now is to go to our clients, because some of the work is also on the clients. On your clients is where you do things like creation of offers, creation of local descriptions, remote descriptions, handling of ICE candidates, stone servers, and all of those likes. So that's what we're going to do. So we want it such that immediately our clients gets into the web page, we want their video to pop out. That's what we want. So let's set that up. So local client video basically means our own video, and remote client video would mean whoever is joining us. So this particular application is actually constrained. The backend is not constrained, but the front end is constrained to just 2 users. So that means at the same time, only 2 users can be in a call. That's just a little constraint on the client side. All right, which is something that can be easily removed, something that can be worked upon, can be enhanced. I mean, you can enhance it. I'm going to make this open source, so you can basically get it and enhance it. The idea would just be to dynamically spawn video elements rather than having to add code. So you'll notice that I'm currently add coding the video elements within my HTML. All right, I'm add coding those 2 video elements. So instead of hard coding, the idea will just be to dynamically spawn as requests come into play. But I'm not gonna go into all of those for now. We're just gonna take it slowly. So let's test this out and see. Okay, so you can see the video component, but it is not coming up. So do we have an error? Oh, I see. It is cached. It is cached actually. It is cached. So if we check the network, check JS, let's see, index is cached. So what we want to do is to do hard reload. Alright, so that. So I requested for a video. Yeah, that works well. Okay. So yeah, so this is the it is messing up. So I'll just post this. Okay. So this is the local client's video showing up, and the remote client's video, that's the person who's going to be joining in, is going to be showing up here. All right, and this is the camera information that we just okay, so that works. Okay, so let's declare some variable. This looks great actually. This looks pretty great. So we need an input box to be able to allow our user either create a meeting or join a meeting, right? So we're going to have more like an input box here. So with that, we can, if the meeting was created by myself, that makes me a host, all right? So the meeting link is going to be there. So you can simply copy the meeting link and share it to your friend to join the meeting. And also, the remote client can copy the meeting link, paste it there, and join the meeting. All right. So we need something like a text box and probably just two buttons that says join meeting or create meeting, that kind of stuff. It's looking like it. Isn't this looking like a Zoom call? Let's dive right in, guys. All right, so we've been able to achieve a number of things. Now you would notice that my frame shows on this particular side of the video because I'm the host. My client who is going to be joining in should show on this smaller portion. Alright, so we've been able to achieve a number of things. Now you would notice that my frame shows on this particular side of the video because I'm the host. my client who is going to be joining in should show on this smaller portion. And also we are now able to create a meeting. So when you click on create meeting, you'll notice that it gives you this room ID. We know that it's room ID underneath, under the hood, but it is to our client called the meeting code, right? So anybody should be able to click on this, do a copy. Our client should be able to paste this and join the meeting. And once they join the meeting, they should be able to show up on this aspect. So that's what we're going to be working on right about now. All right, so this. So this guy is going to be creating the meeting. We have the meeting link, and this guy is going to be joining the meeting. So we say join meeting. All right. Yeah, join through. So notice that we got the message here saying join through, right? And it's just what I told you about. The reason why we are not getting join through here is because this guy is the client that actually initiated the action to join the meeting, right? So it doesn't need the notification that he joined the meeting. The only person that needs the notification is the other client in the meeting, if that makes sense to you. So yeah, this works. Let's see network tab, WS, let's check message. So you can see some traffic going out here. So this sends a JSON message to say join the meeting. And if you check this guy as well, go to WS, you go to join meeting, you will see it's receiving this join meeting. All right, so this worked perfectly. We are able to create a meeting and we're able to join a meeting. So now we can go ahead to just pause the video. So you can go ahead to start creating offers and the likes. So now I would say if message dot join, right? Because we saw earlier that the message that was sent is join true, right? So we're going to use that as a flag. If message dot join, This looks more like it. We're just going to test this out. A number of things might blow up. We'll see. So let's test this out. Refresh. All right, so let's create a second client. Okay, so this guy is gonna be creating a meeting, created the meeting, and this guy is going to be nice elements. This guy is going to be joining the meeting. Okay, we have a couple of errors here. Let's deal with. Okay, so calling other errors, we are creating a file, cannot read undefined property of send. Send 160. Okay, WebSocket. It says WebSocket is undefined. WebSocket. Okay, so it's actually undefined because we did not say WebSockets equal to sockets. Right, so Let's try again. Okay, so try this again, try this again. So we create a meeting, copy, and we join the meeting. Okay. So a number of things. Let's see, founder is candidate. So this worked very well. Let's see this guy. On court reference, offer is not defined. 104. So actually, so this is the offer that I was talking about. So what you see here is the offer object, right? So that's the offer object, and you can also see the ICE candidates. So there are a number of ICE candidates. So what we need to do is to check out for this error 104. 104 offer. Okay, this ought to be message dot offer. Okay, so create a meeting and there's the meeting. So you can see that it's actually trying to load up the client. It's trying to load up the second video, but something went wrong. So let's see what went wrong. Received track, WebSocket is already closed. So let's see why this got closed. Concurrent write. So I came across this error previously. Right, so let's do a go run. Looks work well. Let's do a refresh here, and let's do a refresh here. So let's do this. Create a meeting, copy the meeting, paste, and join. Okay, yeah, so you can see the second person over here. So all right, so this, and also you can see the person over here as well. So this is going to be like, this person created the meeting, and this ought to be the person joining, and this is the remote person joining. And yeah, so if this was deployed, basically you would have seen the other person, but obviously I'm the one testing and I'm the one doing the same at the same time. So yeah, however, there's still a problem. If you notice, our Go code is still failing. We still have the problem of concurrent read, concurrent write. I really do not know how to fix this. All I know to do is to place a lock, and it seems placing a lock isn't working, so I need to figure out how to fix it. However, the basic concept still stands. We are still able to figure this out. So we have this working already. I just need to figure out how to solve that concurrent read, and that should be it, guys. I'm just going to spend some time to figure out how this works, and let's see how it goes. Hopefully I'm able to get this sorted. Do well to subscribe if you're not subscribed, so you can get notified when the next video comes up, and leave a like in the leave a like in the like section, leave a comment in the comment section below, and give a thumbs up if you enjoyed what you've watched so far. See you guys on the next one. So you can see me on my screen and you can see me here. Thanks to Streamify application. Bye guys.